In this session, I'll kind of start with a bit of background about CitationGecko in terms of where it comes from, the problem we're trying to solve. They'll go into a bit about how it works and a little demo of the tool and how to use it, and then wrap up with a few slides on kind of my plans for the future of the tool. So yeah, I should say it's kind of a tool on a smaller scale, I guess, than open knowledge maps. It was kind of a project I developed in my PhD as part of one of the eLife innovation hackathons that they do, and then it was later supported by JISC as part of the Student Ideas competition, which gave us some funding to kind of keep it going. And yeah, I think to kind of echo Peter, really, I should begin with the caveat that in its conception, you know, it wasn't really designed with bibliometrics in mind or kind of evaluation. I know that some kind of librarians and other bibliometricians have found the tool useful, but really it was a tool born out of my own frustrations as a PhD student, doing a literature review and just trying to get a handle on all the different papers relevant to my work. And yeah, this is a problem that I'm sure anyone who's kind of done any kind of research can relate to. As Peter said, there's just an ever increasing number of scientific papers out there, spread across a growing number of journals and now preprint servers as well. And kind of staying on top of this is all really hard. So I'm sure you've been in the situation, as Peter alluded to, where you're on Google Scholar, you go through this list of cited references, you're opening up in new tabs, and then each of those cites another 10 or so papers that seem relevant, and pretty soon you're drowning in all these papers with no kind of idea of how they're fitting together, which you should read first, which ones you've already actually read or got open in some other tab. And in this situation, it's very easy for actually quite important papers to kind of slip through the net, and it takes a really long time to actually get your head around this whole thing and feel like you've got a handle of what's going on. So I wanted to build a tool to kind of help address some of these problems, which, to kind of break it down, is first of all kind of help me discover the new papers that are relevant to my work. The second is kind of helping prioritize and decide what to read first, because as Peter said, if you just have a massive list of papers, it's almost overwhelming. And finally, again, to actually see how these papers kind of fit in the context of everything else, which again I think is really important for that psychological aspect of feeling like you have a handle on things. So, you know, in many ways, trying to solve a very kind of similar set of problems to open knowledge maps. We take a slightly different approach for using kind of different use cases, I guess. Personally, I found that kind of keyword searches didn't work so well for me for certain things I was looking for during my PhD, either just because of differences in terminology between different papers, or gene names varying across organisms and things like that, or just because the thing I was looking for was just quite hard to put into a search term. If I was looking for all papers that are doing this kind of similar type of technique that doesn't really have a specific name and things like that. So the approach that we take with CitationGecko is kind of, instead of having to define your kind of area of interest with keywords, you instead start with some key papers or seed papers, as we call them, which are going to define the kind of query of what you're looking for. Now, you can just start from a single paper and work from there, but it kind of works best if you have 4 or 5. You can use more, but it will get a bit slower. And these needn't be defining a kind of broad field in a traditional sense. They can, as I said, all be papers that use a similar methodology or are trying to solve a similar problem. So you can make the intersection of these papers as niche or as broad as you want, depending on what you're looking for. you might even want to actually use seed papers from two completely different fields that are completely unrelated. And as we'll see in a minute, then CitationGecko can help you try and find any papers where these two fields might overlap, or somebody has thought to combine them in the past. If you're maybe thinking of striding out into a new combination that no one's done before, it might help you see if actually that path has been trodden. So starting with these seed papers, we then kind of search out all the forwards and the backwards citations. For this, we make use of the Open Citations corpus, who I think you've heard from in last week's session. And that's really been a fantastic resource. It's super easy to use. And also, obviously, Crossref, the Crossref API, which is great for all the metadata on each of these papers, and for the references. We had originally been using the Microsoft Academic API, which was actually really good just in terms of the coverage of those non-open citations. Unfortunately, they've discontinued their Graph API, which is a real shame, because it had quite good coverage of the literature. But the system's built in a kind of modular way, so we can plug in other data sources. So I'm looking at kind of adding Europe PMC, which has a bit more data at the moment, and always kind of on the lookout for adding more data sources to increase that coverage. So now we've kind of discovered a load of new papers, and this brings us to the second point of trying to prioritize a bit what to read. And so for this, we kind of define some metrics. And the most kind of basic level, what we do here is we just look at the number of the seed papers that are cited, if it's a kind of a more recent paper, and the number of seed papers a number of seed papers that cite another paper. So and then this depends exactly what you're looking for. So the thinking here is that if a new paper that's just been published, happens to cite one of your seed papers, it could be for any number of reasons, kind of unrelated to what you're actually interested in, because people are citing each other all the time. But if it is citing all 6 of your seed papers, then there's a much higher chance that it's actually relevant to this specific thing that you're looking for, whether that's a particular field or a particular methodology or whatever it is. And similarly, if all 6 of your seed papers are citing the same paper from the past, then it's probably something foundational to the field, or something at least worth being aware of if you're new to the field and you need to kind of brush up on that background reading. And so that's the very simple metrics we use to kind of prioritize the papers. I think in the future we could incorporate some other metrics of relevance. So I think you might want to also add some weighting to the total citation count across all of science, but primarily we weight it just based on the local relevance. And we also kind of avoid putting any kind of numbers on these things, again, just to avoid numbers being misused. So it's all very kind of local and specific to your specific query, and avoiding those kind of global metrics. So the next stage is to kind of visualize the citation network, so you can again start to get this picture of what's going on and see how things relate to each other. And this is, I'll show you on the actual website in a moment. It'll be easy to see, but we essentially have 2 forms of visualization currently. One is your kind of traditional force-directed layout, which I'm sure you'll be familiar with if you've ever seen other citation networks visualized. One thing we do here to try and make it a little cleaner and easier to interpret is we only display the edges between the seed papers. So citations coming to or from the seed papers, because obviously these other papers might cite each other, but if you put that in, it just becomes a massive tangled mess and you can't see anything. It's not useful for anything. So this is just to show you which seed papers these other papers connect to. And again, the size of the nodes is weighted by how many seed papers it's connected to, so that you can, your eye is drawn quickly to the more relevant ones. And the other view we have is a timeline, just so you can see it in the context of when things were published, which is often quite useful. And this also allows you to see the forwards and backwards citations at the same time, whereas in the network view, we only show either one or the other, depending on what you're looking for. The next kind of aspect, which again I'll demonstrate in a minute, it's probably easier to understand, is actually interacting with these networks to kind of iteratively refine and construct your kind of final map. So this contains two stages. The first is kind of, I call expansion, which is if you do find a paper that looks interesting, seems relevant on the same topic as your seed papers, you can mark that as a seed paper, and again it will then find all of the forwards and backwards citations to it and kind of add it to the map. And so in this way you can expand the network and discover more papers. I think equally important, as Peter kind of mentioned, is actually being able to get rid of the irrelevant stuff and hide it. And so you can mark these papers as relevant, remove them from the network, and then they'll never come up again, even if other papers cite them in the future. So yeah, I'll do a demo of this because it's slightly easier. So I hope, I think you can still see the screen. There's a number of different ways you can kind of input these seed papers to get started. You can just search for papers with a text search. This just uses the Crossref API. You can import from BibTeX or from one of your reference managers, so Zotero or Mendeley. And so this will just allow you to kind of pick a folder from your Mendeley library and then import the papers from that. For now, let's do BibTeX just because I've got one ready. So you upload your BibTeX, which defines the seed papers, which are then displayed here. And then you have the visualization on the right-hand side. Let me make this window a bit bigger. And so, yes, you can kind of click down the list view to highlight the actual paper and all the things it's connected to, or you can go the other way and click on the papers in the visualization just to see what the paper was. As I was saying, you can, if you find a paper that seems relevant and you want to add it, you can add that into the network, and it will update all the size of the other nodes and fetch all the citations for that node. Similarly, if there's something that you don't care about, you can mark it as irrelevant and it will be removed. There's also, as I mentioned, the kind of the force-directed layout, which shows you it in this other way. Again, you can kind of hover or click just to see what the paper is, and you can switch between. Here we're showing the papers that are cited by the seed papers, or we can look at the citing papers. Yes, that's how that works. And there's a few other bits and bobs you can do. Is you can apply some more filters. So yeah, by default, we're hiding the papers that have been marked irrelevant. You can obviously cancel this if you want to unhide them and get them back. Or you can add filters by time, by journal, or by the number of seeds cited. So yeah, if you don't care about all these papers that only have one seed paper cited, then you could filter to make sure you're only seeing the more relevant ones. So yeah, and then you can save the session, which just again exports the seed papers as BibTeX, so you can do the same again, or you can export the full list of all of the relevant papers that you found to go and then do something else with them. So yeah, that's a very quick kind of run through of what it does. I think I'll just go over briefly kind of the kind of advantages and the limitations of the tool. So one of the things I see as the advantages is you can be quite specific with the set of seed papers that you give it. So I was using in my PhD things like PubChase and ReadCube, if you've used those, which again use machine learning to kind of generate you a list of recommendations. But often for any of these machine learning based approaches, they tend to need quite a lot of papers to start generating good recommendations, or at least they did back a few years ago when I was doing my PhD. And so with this approach, you really only need a few papers to actually get going and get some recommendations. It can be quite flexible in terms of if you're looking for either doing a review and looking for those important foundational papers and kind of those old papers, or you actually using the tool to just find the new papers that are citing a lot of the stuff you're interested in, and find those, just keep on top of the latest literature. Or again, as I mentioned earlier, you could use it to actually find papers that intersect two distinct fields. I think using the kind of citations as a metric of relevance is reasonably reliable. I mean, there's obviously a lot of problems with citations, but compared to kind of inferred links between papers based on similarity of text or co-readership and that kind of thing, with citations, an expert in the field has made a statement that this paper is relevant to this paper in one aspect or another. And when you could then combine that across multiple papers, it cuts out a lot of that noise of stray citations about things you're not interested in. It's also very simple. There's no magic going on. It's kind of a very straightforward thing it's doing. It's basically just automating what I was doing anyway with Google Scholar, but making it a lot quicker and adding the visualization to give you some context. And that also allows it to be quite transparent in terms of, exactly why this paper is appearing in the list and exactly which papers it relates to. And finally, you get the visual aspect of being able to see what's going on. There's a few kind of limitations. First and foremost is the data coverage. Because we're using the open citation corpus, the initiative for open citations has been great and has really liberated a lot of this data, but unfortunately, there's still a few big publishers holding out, and so there's it's still not going to have as good coverage as Google Scholar. And I think to be a really useful tool, it needs to have almost 100% coverage is what you want. So so that's something to work on. And also kind of in the scalability, there's some scalability issues in terms of if you start putting a lot of papers into it, it will crash the app. Just depending on your computer, either it will die on the API requests being sent, or it will die on the visualization, especially if you're in the force-directed layout. So in terms of kind of the future directions, I think development on the tool has been on a bit of a hiatus while I've been finishing off my PhD for the last year. But now that I'm done with that, I'm keen to address some of these issues. So looking at further data sources, again, maybe returning to the Microsoft academic graph. Although the API isn't there, you can host it yourself and still make use of the data. So I might try and do that. Just addressing some of the scalability issues in terms of shifting more of the API requests onto the back end, and like reducing the animation on the force-directed layout, just so that it will render with higher number of nodes. I'm also very keen to include co-citations in there. As you heard from the co-cite people last week, I think it's a really good measure of relevance and way of discovering papers. Papers that may have been published around the same time, and so they don't directly cite each other. And so yeah, that's something I originally wanted to do with the tool, but it doubles the number of API requests you need to do. So I'm interested to talk to the co-cite people about how they're kind of doing that. And finally, just a more complete reference manager integration. So you can kind of pull in papers from your reference manager, but ideally you also want to directly add papers back into those collections in your Zotero library or your Mendeley library, so that you're keeping track of everything in that reference manager. I also think it'd be really useful to in these visualizations to be able to see at a glance with colors or elsewise which of the papers are in your library already and which aren't, just so you can quickly identify papers that you've never come across before versus papers that are in your library somewhere, and so maybe are less important to have a look at. So yeah, those are kind of my plans. If anyone's interested in the kind of implementation, it's all kind of open source. It's on GitHub. It's using React on the front end and Node.js on the back end. And it's tried to be constructed in a kind of modular way, as I said, so that we can add in just import modules, export modules, and other data, or even visualizations. And yeah, contributions are kind of very welcome. So yeah, just to finish off, I'd like to thank Goodwin Gibbons, who was involved in the kind of the original conception of the idea, Vot and Vishnu, who've been helping out on the development side, and then Eli and Jisk for their support as well. So yeah, thanks for listening, and yeah, happy to take any questions.
Thanks very much, Barney. Zosha, can I ask her any questions?
We haven't had any coming on the Q&A. There's still time though, so if people have questions, please put them in. I had one question for you though, which nobody snuck in a question at the last minute, so I'll indulge myself. You talked about using CitationGecko to look for links between what seem to be completely disparate fields. And I wonder if you could kind of expand on that and maybe give some examples, because it sounded like a really interesting use case.
Yeah, so what I mean is, so it's something you can only kind of really do in the kind of the force-directed mode when you're here. But essentially, if you were to what's a good example? So, for example, if I had a bunch of these seed papers that are about the type 6 secretion system, as these are, which was what my PhD was on, and then you had a bunch of papers on some specific method, for example, that isn't commonly used in this field, and you then added those as seed papers, what you'd probably see is you just have a separate cluster of papers over here where their citation network is kind of independent from this other field. But what you might be interested in is if there is that one paper which is citing both some of these fundamental background papers of type 6 and is also citing some of these methods, or even kind of fundamental papers from a different field, then that would be a very interesting paper to read. So yeah, that's kind of, does that make sense? That's what I meant.
I was going to ask a question as well to take advantage of my role as chair, but it was exactly the same question that Zosha just asked. So clearly great minds think alike. But you know, we know that it's difficult enough to keep up with the literature in one's own domain, and obviously you experienced that as a student, but so much research is interdisciplinary these days that you're having to navigate the field. You're having to navigate more than one field, aren't you? And try to make sense and know where to put your efforts in to keep on top of the literature.
Yeah, and I think one of the things I'm keen to do with the deeper integration with the reference managers is, yeah, if you are, keeping all the different kind of fields within your interdisciplinary area in these different collections in Zotero and Mendeley, and then just being able to switch between them on Gecko to just essentially check for any new papers within that field, and if it is, you can just quickly add it into the collection. And so just to be able to kind of stay on top of those various subtopics within your research, because yeah, I think often when you're doing any kind of research project, it rarely falls into, oh, this is all I'm interested in is this one field. It's usually made up of a subset of things that you're interested in, and actually the more specific you can be with those sub collections, then the more likely you are to kind of get useful recommendations, rather than just chucking all of your papers together and getting one massive list. So yeah, that was the kind of thinking behind it.